So in the last video, I talked about how to find the degrees to the polynomial. And in this part, I will be solving and simplifying the equations for the polynomials. First, we are gonna look at how to add, how to do addition or adding in polynomial. So here we have an equation of 4x squared plus 6x plus 7 plus 2x squared plus 1 minus 9. And then in order to solve that, first we should remove the parentheses. So we're gonna assume a 1 and multiply the parentheses, everything in the parentheses, to 1. And then for this term, we're gonna assume 1 as well, plus minus 9x. It's gonna give us the same answer just because we're adding it, and the 1 is also positive that we're gonna multiplying it with. But when we do subtraction, the signs in front of the term, they do get changed, and if we don't do that, we might get a wrong answer. So it's gonna be 4x squared plus 6x plus 7 plus 2x squared plus 1 minus 9x. So in this, we're gonna look for like terms which are similar. So 4x squared and 2x squared, they are similar. We're gonna write that first. So 4x squared plus 2x squared, and then we have never mind. And then we have 6x squared and then 9x squared minus 9x squared. We're gonna write that plus 6x minus 9x, and then we're left with plus 7 plus 1x. Plus 7 plus 1. So now we're gonna add these two together, like terms, and these two together, and then these. So here we're gonna get 6x squared. Remember, when we add the terms, we only add the number part, not the variable part. We keep the variable part common. And 6x minus 9x give us 3x, plus 7 plus 1 is 8. Here, this is our final answer. We cannot simplify it more because we don't have like terms. So this is, it is 3 terms, so it is a trinomial polynomial equation. So it's trinomial polynomial equation. So now we're gonna solve one more example for the addition. And then in order to solve that, we're gonna do a same thing. We're gonna try to assume 1, and then we're gonna multiply that by whole thing. So it's gonna be one into x squared y plus xy plus minus 3y squared plus 5, and then plus 1 again, 2xy plus 6xy squared minus 4x squared plus, never mind, 7, it's 7, my bad. And then 7. And we're gonna get the same answer again if we multiply this, and then this, and then this. So we get, let me just remove it for a second, and then we get plus xy minus 3y squared plus 5 plus 2xy plus 6 xy squared minus 4x squared plus 7 and then we're gonna look for a like term. So we have x plus y, xy, and then we have 2xy and xy. We can combine those together, and then we can get 3xy, and then we can do, so it's gonna be x squared y plus 6xy squared, because we as I mentioned, we write the exponents in descending order with the higher value and all that. So it's gonna be y squared plus, we're gonna add 2xy plus xy, which is gonna give us 3xy, and then we have 4x squared minus 4x squared, and then we're left with 3y squared plus, we're gonna add 7 and then 5 because they're like terms. 7 plus 5, we get 12. That is our final answer because there are no other like terms that we can solve for. So this is a polynomial equation because this has 1 more 3 4 or more terms in this, and we're gonna do the similar thing in order to solve the subtraction polynomial equations. So first we are gonna assume 1 in order to remove the parentheses, 2x cubed plus 5x squared plus 3x, and then minus 1, and then x squared minus 8x squared plus 11. Now when we multiply this by all of this, we get 2x cubed plus 5x 3x minus, now this will change the signs, minus 1x into x squared is x squared, minus plus minus 1x, minus 1 into 8x squared is plus 8x squared, and then minus 1 into 11 is minus 11. Now we're gonna look for the like terms. In this we have 2x cubed, and then we have x cubed. Wait, never mind. Wait, this is x squared and x squared. So this is gonna be we keep the 2x cubed plus 5x plus 3x gives us 7x minus, we have x squared minus 8x squared gives us 7x squared minus 11. So that is our answer for this question. For the next question, we're gonna solve the same thing, and then 4x plus 5x minus 1 into x squared plus 3x minus 2. We get x cubed minus 4x plus 5x minus x squared plus minus 3x plus 2. So in this we're gonna find a like term, which would give us 3x. There's no similar term for like 3x, so we're gonna write it as it is, x into 3. And then we have x squared, and then we are gonna add 4x minus 4x and minus 3x is 7x minus, and then we have plus 5 plus 2, we get plus 7. That is our final answer. So that's how you solve add and subtract polynomial. One thing to remember here is when you add or subtract two terms, just keep their variable as it is and look for similar terms that are alike terms to each other. Next, we're going to talk about properties of exponents in scientific notation. In this, we're going to solve a simplified expression using properties of element. When we simplify polynomial expression, we apply the key exponents rule. So the first rule is a product rule, where a term, for example, a power m and a power n get equals to m plus n. We add their when we multiply, we add their exponent values in order to get the example. For example, here we have x cubed into x5, and we keep the x as it is, and we add their exponent values, which would give us 5, 6, 7, 8, which would give us 8. So this is similar to finding degrees, but in this you just keep the value added to the term. And then we have one more example where we solve it. In this we have 2x cubed and 2x cubed y squared into 5x 4 and then y cubed. So first we're gonna multiply 2 into 5x, 2 5s are 10, and then we add the exponent values. For the x we add 3 plus 4, we get 7, and then we add the values. For the y exponent we get 5 because it has a value of 2x plus 3x. We get a value of y. And then there is the next rule is a power rule. For the power rule, we have equation in the bracket, and then we have its power, and then we have another power for the whole equation. But we keep the number part as it is, and we add the values of exponent values. When raising a power to another power, we multiply the exponent. So we multiply m into n. For example, x cube into 4 has x, and the whole thing has a value of 4. So we multiply the exponents together, we get answer to 12. And then there's another similar example, which is 2x squared y cubed, and then the whole thing has a cube root. So in this, we are gonna multiply everything inside the bracket by 3. So we're gonna multiply first 3 by 2 is we're gonna multiply 2 in 3 times. So 2 into 2 into 2, we get 8. And then we're gonna multiply the exponents into 3, so we get 2 exponent of x into 2 into 3, we get 6. And then for y, we get 3 into 3, we get 9. So our total answer that comes is 8x into 6, and then y to the power 9. Next, we have a quotient rule. In the quotient rule, where we divide, we keep the number part same, and then we subtract the exponent value. When we divide with the same base, we subtract the exponent value. For example, x over x, x has a power to 7, and then x has a power to 3. We're gonna subtract 7 minus 3, and we get an answer to 4. Then here we have another example with the numbers, where we have 12 over 4x, and then x to the 5, y 4, and then y to the 2. We are gonna try to separate it. So we're gonna keep 12 over 4 here. We're gonna cancel 1 into 3. And then we're gonna subtract these two terms. So 5 minus 2 is 3x, and then y4 minus y2, we get y2. So that is our final answer. And then next we have a distributive property rule. Distributive property rule is when we have a number term when we have the terms in a bracket, and then we separate them and we solve them together. So just like I did the other previous example up there, here this is the similar example. So we just distribute the exponent power, the whole power, to the exponents and multiply it together. So here we multiply 3 by 3 times, and then x into 3, we get 3. Because x has a power to 1 here, x has no power here. And then we multiply 3 into 2, we get 6. So we get our final answer as 27 into 3, 27x 3, and y to the power 6. And then next we have negative exponent rule. When we're solving these properties of exponents and all that, we sometimes get the power to the negative rule. A negative exponent move the base to the denominator. For example, we have x power minus 4. We're gonna assume 1 and then keep it to the denominator. We can get rid of the minus 4. And then next I have another example of 3x minus 2 over y 3 divided by 2y minus 1. We're gonna keep the x on the denominator, and we're gonna keep y on the top. So for this, we are gonna find alike terms. We're gonna add 3 plus y1, we get exponent power of 4. And then for here, we get 2x squared, and then we're just gonna keep it as it is. Because we don't have similar like terms, we cannot really cancel those both. So Now we're gonna simplify these questions. We're gonna simplify the exponent rules with the rules. So first I have is 6x squared over y minus 5, and then 9x minus 4, and then y cubed. So for this, I'm gonna try to write them separately, and then solve those. This is 2, this is minus 4, and then y is minus 5, and then y is 2. So I'm gonna it's gonna be 2 over 3, and then I have Then I have 2 minus 4x, and then if we minus them, it's gonna be 2 minus 4 minus 4. There's gonna be a plus sign here because they're both minus, so it's gonna be 6. And then if we minus these 2 minus 5, and then minus 2, we get 5, 6, 7. So our final answer is 2x to the power 6, and then 3y to the power 7. That is our final answer. And for this, here we have 3x, y, and then y to the cube, and then 2. We're gonna multiply everything by 2 here. So we're gonna do 3 into 3 is 9, and then x into 3 we get x to the power 3, and y 3 into 3 we get y power to the 9. So final answer is 9 x to the 3, and then y to the power 9. No, wait, that's gonna be a power to a 6. I'm actually making so many mistakes. If we multiply 2 by 3, that's gonna give us 6. So it's gonna be y to the 6. And then for the next question, we have y to the power, everything to the power minus 3. So if it is a minus 3, we're gonna separate it at first. 2 over 3, and then x to the 3 over x, and then y to and y itself. And then we're gonna multiply everything by 3. We're gonna multiply the top by 3, and then we're gonna multiply bottom by 3. So we get 2 times 3 is 8, and then 3 times, if we do it 3 into 3 into 3, we get 27. And then for the x here, I'm sorry, I'm just gonna erase it first. Oh no, never mind. For the x here, we have x to the cube minus x, we get 2. So we have 1 here, and then if we minus both of these things, we get 1. We get just 1. We get 2. Never mind. I'm sorry. My head is just. We get 2, and then we multiply that by 3. We get x to the 6, and then we have y minus. If y to the 2 at the bottom, if we have 1 here, we minus 2, we get 3. So we get y to the 3, and then we multiply that by 3, we get minus 9 here. That is our final answer. And then y to the 2 is, actually I'm making mistakes here. We get y to the 1. I'm sorry. Oh wait. So in this we have y square and y over y square. If we minus that, we're gonna get y minus 2 minus 1, we get y to the 1. And then if we multiply that by minus 3, we get minus 3. That is our final answer. And then we have a next similar situation, which is 3 over 4 and then x to the minus 1. If there is x 1 minus and then minus 1, we got x to the 2. And then we have here y, which is y minus 2 and then y minus 2, which gives us y to the 4 and then x to the 2. That is our final answer for this. In the next part, we're gonna simplify scientific notation. Scientific notation is a way to express very large or very small numbers in a form where, for example, a into x power n, where a is a number between 1 to 10, or it could be greater than 1 to or smaller than 1 to 10. And then n is an integer exponent that shows how many places decimal moves. So in the first part, we're gonna converting number to a decimal notation. In part A, if we have a large number, we move the decimal to left. And increase the exponent or multiply by positive power of 10. We multiply that power of 10 and then we get, for example, here we have 45,000,000, and then it is 7 decimal points. So we're gonna put 4.5 into 10 power to the 7, because it has like we moved the decimal to 7 places ahead to the left side. So we're gonna add the value of 10 to 7. If we have smaller numbers, if we have a number in like minus or like negative numbers, then we move the decimal to right side, to this side, and we multiply negative number with negative power of 10. So here I have 0.00032, and then I move my decimal to the right side and move it 4 spaces, 1, 2, 3, 4. Then I add the power of 10 to 4. In the next part, we have multiplying number in scientific notations. In this, we have a same product rule. We keep the number part and we multiply the number part, and then we add the values just like we did it previously. We add the exponent value and keep the 10 as it is. For example, we have 3.2 into 2.5, which is 3.2 into 10 to the power 4, and then we have 2.5 10 to the power 3. We multiply the coefficient and we add the exponents here. So we multiply 3.2 and 2.5, and then we keep the 10 as it is, and we add the exponent values, which is 4 plus 3 is equal to 7, and then we multiply this, we get 8.0. And that is our scientific notation for multiplying the number. If we divide, as I mentioned earlier, we're gonna minus the exponents and subtract the exponent and divide the coefficient of the value. The equation we have, for example, we have 6.0 into 10 power 8 and 2.0 into 10 power 3. So here we're gonna keep the coefficients on the side, and then we're gonna divide those, and we get 3.0 into 10 to the power 8 minus 3 is equal to 5, 10 to the power 5. So that is how we solve and simplify the scientific notations. Now I'm gonna try to do some examples here for the scientific notations, which is we are gonna multiply this first, and then we have 1.3, and then I'm gonna keep this, and then I'm gonna multiply it with 7.2, and then I'm gonna keep 10 as it is. 10 as it is, and then I'm gonna add the values. 5, 3 plus 5 minus 5 plus minus, I get a power 10 to the 2, and then 1.3 into 7.2 is equal to 99.36 into 10 to the power 2. So that is our answer for this one. And then for the next one, I have 6.3, and then we're gonna keep this 6.3 over 2.1, and then I'm gonna separate those. So I'm gonna keep the 10 as it is and subtract these minus, and then I have minus 2, which would give me minus plus, so it's gonna be 10 minus 7 plus 2, and then it's gonna end up getting minus again. It's gonna be minus 5. So I get 10 to the 5, and then if I divide 6.3 divided by 2.1, I get 3. So my answer is 3 into 10 power 5. So that is all for the simplifying scientific notations and properties of exponents and scientific notations. In the next part, we're gonna be solving about how do we multiply the polynomials.